Welcome to moisture content and density relationship, whereby we'll be using standard proctor mold and the armor, whereby the armor will be under the sheet and the collar, and we have the total height as 103. Now we are looking at this one in honor of BRR Proctor, whereby this one it was invented by a scientist. The relationship of dry unit and moisture content. We have various materials when we are conducting the same practical. We have the pan, we have the hammer, we have the mold, we have the brush, and we have the vacciner, we have the chips, and then we have the brush. We also have the mold, we have the teeth for moisture density, and then we have the weight balance. First, before we do anything, we measure our mold. We pass our sample through sieve number 4, whereby now all materials that passes around the sieve through shaking the sieve, and then we have our final fine particles of soil. Here comes now we divide our final specimen into 4 different parts, but the 4 different parts now fall in a category of different moisture content, but having constant distribution of the moisture content. Let's say when we have the first as 2% water content, second one will be 4% water content. So we mix truly, we add the water in the same soil sample, and then we mix it truly. After we have mixed it truly, we take the water sample into the pan and then mix it with the use of the trowels. With the aid of the trowels, we mix it evenly. We make the first sample of the soil. After we have mixed it with the water, we take it to the mold. We build in 3 layers in the mold. The first layer we input around halfway of the soil content. We run it through by the use of hammer, having 25 blows per layer. We distribute equally the flowing or the blows by the hammer. Then we add the second layer to the mold. We distribute again and we hammer it 25 blows. These distribute by use of equal distance, the same bull height of the same hammer. After we have achieved the distribution, we build in the third layer, whereby now the third layer will be up or will be raised above the collar of the mold. After that now, we open the collar of the mold. We open the collar of the mold. And with the help of the straight edge, we cut the above layer, above the mold. We trim it equally. We trim it to the level of the mold. After we achieve that now, we say we have the optimum or the correct volume that dies with the mold. We clean the whole outside of the mold to have the actual size or the figure of the mold. After that now, we take our mold plus the soil sample, we weigh it, we have the final weight of the mold plus weight of the soil sample. Then now we open our mold and then pick the soil sample for testing for dry density. The samples we pick for dry density, we pick it from different parts of the soil sample we had in the mold. We also have to measure the weight of the mold, or we can automatically factor in while we are doing the calculation in terms of when we are doing the weighing on the machine. We weigh the soil samples before we take it to the oven for drying for 24 hours. After that now, we close our oven for 24 hours and let our moisture content things experience the above atypical. Now, after 24 hours, we bring in the use of the use of after 24 hours, we bring in now our results from the oven. We also weigh the same materials. After weighing, we now have our typical results. We plot a graph using the same figures, where now we have the diameter of the mold, whereby it gives us we have for trial 1, trial 2, and trial 4, number by layers of the figure. We now have the moisture level and the dry density mass of the. Then we have all the first trial, the third trial. This one will help us now to plot the graph. And we find that after we have drawn or we have combined from the graph, we have slight minimums or the fractions of the reductions from the cells, or what we can say we have improved. Now, when your graph is in the nature of a parabola, we have the optimum being the dry density. Now we say thank you for watching and join us in our next class.